Hello. So today we're going to look at another HSC question. This one is a little bit different to the other one, but has a similar function. In this question, it asks us to sketch the graph of y is equal to square root of 4 minus x squared and state the range. Okay. So this function is actually a semicircle. Now let's imagine that we didn't know that yet. So how would we go about sketching it? Well, the trick that you always go back to is finding the x-intercept and the y-intercept. So to find the x-intercept, what we do is we substitute y equals to 0. So subbing in y equals to 0 into this equation gives us 0 is equal to 4 minus x squared, and it's all simply a matter of solving this equation. So what I'm going to do is I'm going to square both sides. Square both sides. Just write SBS as square both sides. And then I'm going to make x the subject, or solve for x. So moving it over. And now x must therefore be plus minus 2. Okay, so there's two x-intercepts in this function. Now let's have a look at the y-intercept. Well, the y-intercept is simply just the value of y when x is 0. So substituting in x equals 0, we're going to get y is equal to square root of 4 minus 0 squared. And that, of course, just simplifies down to root 4, which is 2. Okay, so very easy. So let's highlight our key information here. So these two are our key information in helping us graph. So now I'm going to draw a nice number plane out, and then start putting in the values. So the x-intercepts at plus minus 2, they're about here and here. Okay, so remember this is a sketch. It doesn't need to be accurate in terms of the number plane. As long as it looks like it's at minus 2 and 2, that should be fine. Now for the y-intercept, it's at 2. So it's about here somewhere. Now this is a curve. Okay, when you take the square root of something, it sort of makes any sort of line a curve. So that curve must pass through these points. So logically, it has to look something like this. A semicircle. Okay, and that's basically the first part. You get 1 mark for that. Okay. I guess when you have studied curve sketching, this part where we're finding the x-intercept and the y-intercept, that probably wouldn't be too much of a hassle, and probably you don't have to do as much working. You'll probably be able to sort of see already that you can go straight from this graph here all the way to just drawing the graph out, just like I've done here. So that's why it's worth 1 mark when you get to this stage. Okay, now the other mark comes from stating the range. The range is all the possible y values that this graph can take. Okay. Well, how do we go about finding that from the graph? If you have a look, right, the smallest y value that I have in this graph is when y equals to 0. Like at this point, I've got 2 possible x values. I've got minus 2 and 2. And then I have more y values as I keep going upwards, right? So there's possibly y values here, and so on and so forth. More y values. Okay. All these y values exist because if I put any x value into this function, I'm going to get a y value out. So, for instance, let me just get rid of these arrows so I can show you what I'm talking about. Imagine if I put in the x value of 1. Okay, so let's say I put in the x value of 1, which could be maybe somewhere here. Okay, so that's 1, x equals 1. You can see that it touches the curve. That means that there is some possible y value that exists in this function. And in fact, we can find that. Well, when I sub in x equals 1 into this function, y equals to the square root of 4 minus x squared, you're going to get the square root of 4 minus 1 squared because x is 1, which gives you root 3. So in fact, the value that touches across here would be root 3. So it works for anything here. So basically your graph exists all around here. Are all the possible y values that exist for the graph. Hence, the biggest one would be at 2. And so your range is therefore going to be between 0 and 2. And that's basically the second mark that you can get. Now, if you wanted to find the domain, that would also be quite easy because it's simply just all the possible x values and you can pretty much read it off, right? It starts from -2, there are possible values that exist, and it goes to 2. Nothing exists at 3, right? There's nothing here. There's nothing at -3 and so on. So that's basically how you would find the domain if it asked you to.